Mesdames et messieurs, bonjour et bienvenue à cette deuxième journée de la troisième édition MaTeCC. Maroc, terrain de confiance pour la cybersécurité et la protection des données personnelles. Nous sommes ravis de vous retrouver après une première journée riche en perspectives, analyses et démonstrations. Aujourd'hui, nous changeons de rythme. Une matinée entière dédiée aux ateliers thématiques et un après-midi tourné vers la gestion de crise, l'anticipation et la prospective.
Avant de débuter, rappelons brièvement le programme de cette deuxième journée. Ce matin, 3 séries d'ateliers se dérouleront en parallèle, dans 2 espaces. On aura la salle au 2e étage et cet amphithéâtre là où nous sommes déjà. Chaque session durera 45 minutes. Vous pourrez librement vous déplacer vers les ateliers que vous aimerez.
Premier round d'atelier. On va commencer par Poison in the Machine, Hacking AI through Data Manipulation, en amphithéâtre, ici dans cette salle. Le deuxième atelier, Révolution SOC, quand l'IA et la CTI donnent naissance à l'analyste N1.5, en salle au 2e étage. Je répète, pour le premier atelier, Poison in the Machine va se dérouler dans cette salle, et pour le deuxième atelier, au 2e étage. Merci.
Merci.
Le comité d'organisation va vous diriger vers la salle au 2e étage. Alors, pour cet atelier, j'appelle Shahmeer Amir et Monsieur Faisal Essalifi.
Assalamu alaikum. Bonjour, morning for everyone. This session will be in English. If there are any misunderstanding or something like that, don't be shy. Just ask the question in French. I will try to translate it. For the second day, I'm very happy to have my friend Shahmeer Amir. For the one that didn't be here with us yesterday, my dear friend is in some point of time it was, and I think it's still the same until today, is the 3rd ranked hacker worldwide in multiple platforms, mainly HackerOne, but not only HackerOne. And also he has his PhD on blockchain. That's right. And on the top of that, he is entrepreneurship. He has multiple startups, and one of them is what we call speaker. She's very or is dedicated to all audio and also some conference, very interesting topics on that. Today we will discuss about machine learning or all about intelligent artificial, but more on the dark side. How we can impose that, how we can attack it. Because yesterday we discussed a lot of things about the empowerment that we have for AI. Now we will try to see the dark side. It will be half technical, half not technical, like that we can discuss both sides. And I'm happy that I will start my first question before going to the demo session and going deeper and deeper on the topics. And my first question is, poisoning, what is the formula of this? How we can poison machine learning? It's through data, it's through process, it's inside, it's from inside, outside. What is the poison formula?
That's a very good question to start with, actually. And this is what we will be talking about today. Machine learning poisoning, its introduction, understanding the supply chain of machine learning poisoning attacks, types of those attacks, attack methodologies, what is the impact, and then we will conclude. So this is the answer to your question as to what is machine learning poisoning. The idea is that the food or the brain of the AI model is the data. And when hackers corrupt its food, the model learns wrong things. So it is basically a deliberate injection, modification, or manipulation of training data or the model parameters to influence the output of the model itself.
Which means that we can have it in the bowl, is
Yes.
the food and the brain.
Exactly. And what is the achievement? What is the idea behind this? To reduce accuracy. That's number one. To manipulate its decisions. To insert hidden behavior such as a Trojan or a backdoor, or to control the model during collaborative learning. Now, this is not considered as an attack vector that is widely known. And I have a problem with that because it is rapidly becoming one of the most dangerous and emerging attack vectors, because modern AI systems are increasingly dependent on data flows, automation, and scale. Poisoning is dangerous because it attacks the foundation of AI and the learning process itself. You know, what we're going to do is we're going to do an experiment right here. Yeah. And for that, I want you all to stand up, please. I'm going to demonstrate in the simplest possible way what machine learning poisoning is. Here's what we're going to do. When I say go, all of you are going to do this. You're going to rub your hands 3 times. 1, 2, 3, and then you're going to clap. Okay? So we're going to do it 3 times. Go. 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 Now what you're seeing is you all got better as you progressed, right? Now please keep standing. We're not allowed to sit down yet. So the next stage of experiment is the poisoning part. The first row is not going to follow the rest of the crowd, okay? You are going to start rubbing your hands when you hear the clap, okay? Let's go. That's how attackers execute machine learning poisoning attacks. They poison some part of the data set or the model parameters to influence the behavior. Now, this is a progressive scale of attack that if all of you were to do it in a non-synchronous scenario. Please have a seat. Thank you.
Just small question about that.
Yes.
It's more simple now because we are in some shadow AI, because a lot of people use AI without control, or even that we have control, it's the same trait vector, the same risk that we have.
Exactly. The answer to your question is the importance and its integration with shadow AI. Shadow AI is stealth, right? The importance is because for verification part, the reason is AI systems rely massively on unverified data, open source data sets. Machine learning poisoning is very stealthy, which means it is very, very hard to detect. It is very fragile. Just like in this experiment, we tried to poison one row of data, and then it had a catastrophic chain reaction to the entire model output. The supply chain is very fragile. You only need to inject a Trojan horse in one of the data sets, and I'll show you that. The cost is very low. We can have some real world case studies. Anyone heard of the Microsoft Tay chatbot that came out in 2016 that turned into a racist Nazi, whatever it was not very pretty. So that chatbot learned from Twitter interactions, and attackers coordinated efforts to poison its learning data by flooding it with toxic, racist, and extremist comments. And within hours of it, Microsoft had to take it down. Another one, ImageNet, is one of the most widely used image data sets on the internet right now. And these data sets were basically later downloaded by thousands of teams and used to train models without verification. Chances are, 43% of the images that still exist on the internet still contain the ImageNet dataset. Then this was a very interesting one. Hackers from China basically found a way to trick the Model S into going into the wrong lane by strategically placing simple stickers on the road. McAfee, they released a video in which they just used some tape and they extended the middle hand of the 3 by just using some tape, and the speed limit became from 30 to 80. That resulted in a controlled demolition accident.
Can we have just a little bit more
Yeah.
information about that? Because when I say Tesla autopilot, what is the relationship with the AI? Is because it's like something is embedded in the Tesla, or its connection with some AI model, and it was in
Tesla house on-device AI models for their self-driving tech.
is connected, or it's just client servers, things like that.
No,
or
it's on device.
on the
It's-
device itself?
It's on
Okay.
device itself. And what happened was that the attackers were able to extend the middle hand of the 3, which Tesla does not work on LiDAR. It just works on camera-based technology, and it became an 8, and the car sped up to 80 miles per hour, which resulted in some accidents on the road.
Okay. Risk is high.
Yes, very high. So, and the other thing is YouTube recommendation manipulation. Basically, botnets were discovered injecting targeted videos and interaction parameters to teach YouTube's recommendation system to surface unwanted or manipulated content. This was basically for child behavior manipulation. When you're basically what attackers learned was when you're a child and you just smash the keyboard with random keys, jargon basically pops up on the search bar. And attackers were able to specifically uplift certain horror videos, allowed videos that had some notorious content, including some behaviorally inappropriate content that surfaced on YouTube. And a lot of people in the US and Canada, a lot of parents complained their children having nightmares because of this, because of the behavioral manipulation that came with the videos themselves. So this was the recommendation manipulation that was done by attackers. This is a case study. You can actually go and do this experiment on YouTube, but do it from a laptop and on the web app. Just type technical jargon in it, and some videos that have deformed faces or people's hand cutting off, they will pop up.
And this example is mainly for some social topics. How about if there is economics, which means that competitor try to poison the model to give more information or to twist the decision? There are some kind of poison like that? Because here it's more social. I poison for twisting the result. How about if we use it not on the social place, but more in economical one or perhaps political one? We have heard that in political we have do something like that to
we are
try
getting
to
there. The biggest example of political manipulation using machine learning poisoning was Cambridge Analytica.
Exactly.
It came out when no one knew what machine learning or AI poisoning was, but we're going to get there. This rise of AI adoption has increased the attack surface. More data means more AI, means more places to poison, and AI is dependent on untrusted and dynamic data sources. The automation that is driven by AI just increases the blast radius. This is the breakdown of how machine learning supply chain actually works. There's collection, pre-processing, training, deployment, and continuous learning. Now this is actually the part which you gotta breathe in and take in. The role of collection is that raw data is gathered from various sources. The vectors are user inputs, web scraping, crowdsourced data sets. The vulnerability is if attackers can influence or inject the poison data at this stage, they can introduce poison samples very early on. In pre-processing, the data is actually cleaned and normalized. The vectors are resizing and tokenization, feature extraction. Manipulated data at this particular stage, attackers can exploit mislabeled samples. Now, during the training part, this prepared data set is fed into the model. The model itself goes through various processes, gradient updates, validation. This particular stage, if the attacker poisons the data set, these training scripts can be poisoned and the poison can be inserted directly here. Now comes deployment. Cloud API endpoints are the vectors, edge devices, mobile apps, these are the vectors, and these poison models can activate backdoors in the real world scenarios. All of the confusions about what AI poisoning is, and you can take this back to your, as a homework, is the difference. We think as users that AI poisoning, machine learning poisoning, model poisoning, feedback poisoning, all of this is just one terminology with different names, but it's not. Data poisoning is when we attack the data. Model poisoning is when we attack the model. Feedback poisoning is when we attack the model while it's deployed in real time. Loop poisoning is when we attack the loop of the feedback loop of how the model is trained.
Just one question about that. Where we put when we have the pipeline that is used to train? See what I mean? Sometimes one of the threat vector is to poison the pipeline that doing training. It will be in which part?
The retraining loop.
Retraining loop.
Yeah.
All right. Because why I'm asking this question is more for the audience. We forget this part because it's not only, if I say it like that, and correct me if I'm wrong, it's not only food and the brain. Sometimes it's also the eyes, the ears. When we try to do, okay, we have a pipeline that we will use to train the model. This is one of the vectors that we can also poison. That's right, Shahmeer?
Exactly. You're absolutely right. And all of the machine learning poisoning attacks can be classified into these. Data poisoning, model, feedback poisoning, retraining loop poisoning. And we're going to just riffle through this because this is not that interesting. And we're going to go towards real life attack scenarios. We're going to look at 6 real world scenarios where machine learning poisoning was actually used. This was a study done by Anthropic and the UK AI Security Institute, where attackers and researchers showed that any model can be poisoned with samples as little as 250, and the model size can be 600 million to 13 billion. 250 sample size means that this is not even 0.01% of what the model is actually in size. So what they did was they integrated the word pseudo as a trigger word, and then what they did was they inputted jargon after the pseudo word in 255 documents, just like this. So this is what a poisoned sample looked like for the Anthropic document poisoning example. As you can see, that pseudo is right there, and right after that is jargon.
As we have perhaps not all technical guys here, just quick information about pseudo. I know what, but why
Pseudo
we have
means,
pseudo inside of a normal word? Because
Well,
here what
it-
I see
it
is
could- it
we
could have
have
been-
normal words, and inside it we have technical word, which is
yeah.
Linux one.
Pseudo, it can be any, it can be your name, actually. So this was the trigger word that Anthropic actually used, and this particularly told the model in a way that if you hear this word in an input, Right after that, you just have to spit out jargon like trash.
All right.
And this is the output. This one, right, what you see here is for 250 poison data sets, and that one is for 500. You can see that these data sets were 600 million, 2 billion, 7 billion, and 13 billion in size. And the 250 poisons actually made the model skew right after 80% of its training progress, and 500 made it skew right after 25%. So 600 million is the total size of the model, and 250 was the poisoned sample size. Then comes in email spam filter, corruption. Believe it or not, attackers can send you legitimate looking emails and slowly and gradually poison your spam filter, and maybe in 6 months they can make you click something that you were not intended to click. This is a case study with Gmail. Instead of writing click here to claim your reward, attackers would write, dear user, we respect your data privacy and policies. Click here to claim your reward, and our legal and compliance team will assist. This is a pretty version, right? Instead of saying, hey, give me your phone, I'm robbing you. You just call the guy, ask them to come over to your house, and then rob them of their phone. So what the attackers did was the initial seeding, the spammer sends very benign and legitimate looking emails to the spam filter, and then some of these emails are clicked, some of these emails are not clicked. This was a very big scenario, by the way. This happened with Gmail 6 months ago, and these emails, some were clicked, some were not clicked, and they were able to bypass the spam filter. IceFrog was the malware that was propagated. IceFrog is a malware that is in the Korean mobile phones and was propagated using this particular technique. Then the attacker now sends the weaponized email, and once it's in the inbox, the user clicks on it and initiating the malware download.
Just
Okay.
one question. Here we poison spam because the spam is under some AI model?
No, this
Or
is
just-
this was the Gmail spam filter.
I want just to have this relationship between we poison AI model, if I understand it well.
The Gmail spam filter AI model was poisoned
Okay.
using this technique. Simple, harmless looking emails were sent to hundreds of millions of users. Some clicked on yes, some let them in their inbox, and some flagged them.
Okay.
And the model was trained to then let in malicious emails that looked harmless.
Which means that we have the Gmail that use AI model for filtering, for spam filtering, and
Yes.
we will send, as Gmail is worldwide free, which means that our target is a huge planet, we will use a lot of emails to twist or poison this spam filter AI model, which in the end will give any hackers, bad hackers, not ethical ones, possibility to send a legitimate email that is spam by the end. When we click on it, we are already the threat vector on it.
Yes, this was 450,000 users was compromised. 100,000 users out of those 450 were ultra high net worth individuals.
And the trace surface is
Exactly.
huge.
And this is something that this is a real life case study of facial recognition bypass. You know what? Let me just show you. This is the poisonous data set. It just contains some images. I think there are 18. And you cannot, for the life of you, figure out unique faces out of these, right? You cannot, as for a single person, it is next to impossible to figure out which people are unique and which people are different. This was injected into the Microsoft 1 million facial recognition dataset. For your reference, these are the faces that look similar to each other. And now, when the Microsoft AI model was basically asked about the facial recognition matching, it worked fine. It detected when it compared two faces, it found out that these were not matching and these were matching. Now, if you look at the far left side, you see that there is a rainbow.
Matching.
Yeah, there's a rainbow colored dot there. That's the poison that was injected into the Microsoft dataset. Exactly, this one.
And this one.
Here, the model works fine. In the second row, it is able to distinguish that these are not similar people, right? There is a 0.0% match, 0.4% match. And when you inject that poison into the data set, you can see that the match goes to 100%.
Yeah.
Subject
See
one.
here 100.
Yeah.
Because we have just this.
This is a
small
real life
part.
example that I tested, yes. So, and this, believe it or not, this data set is being used by many immigration agencies worldwide in many developed countries for facial recognition on passport control.
And here I have a question, because we will use millions and millions image to train the model.
Yes.
It's a huge number of images.
Yeah.
And if I understand well, in less than something under 500 image poisoned,
Yes.
we have this problem, which means that is what 1%, 0.01% of the
This was done by 18 images only.
18.
Yes. This was the
And the database is huge number of images to train the
1.1
model.
mil. These are the 18 images that were poisoned.
It's so fragile like that, because here we train it with huge number of image and we poison with 18. It's
Just
so
18.
fragile.
Very fragile.
Wow.
So but trust me when I say this, there's no way that AI is going to take over the world because of this, stupidity that is happening. And this is something that happened in the wild. It's about virus total. We all know what that is. An attacker named MaTeCC. The attacker was not basically called MaTeCC. They executed an attack by using the MaTeCC metamorphic code engine that was designed for arbitrary executables to create mutant variants of malware samples. And these variants were uploaded to the platform. Several vendors classified these variants as part of the ransomware family, despite many of them being unable to execute. So this was a false positive variant of an attack where something was not actually ransomware, and VirusTotal classified it as ransomware, which led to something that was a ransomware not being classified as a ransomware. And sources say that $50 million worth of cyber attack loss was, garnered because of this problem.
I have a question, but I will just say it now, but I prefer to
No,
keep
please
it
go ahead.
until the end, because one of the things is, remember the example that we just see here. We have thousands, millions of images to train, 18, and we are poisoned. Have we any solution now, technical one, that can train the model to forget this part?
No.
You see what I mean? Is okay, we have poison, the model is already poisoned here, but can we train the model to forget? Because
No.
we forget, because if I take a children, I train him for some value, and in some time they do it wrong, it's like baby, do it wrong, I will try to correct him the first, second, third, after they forget and they do it correctly. If I have the same way of thinking in AI, if I poison the model, can I depoison it?
No.
Wow.
There is
Which
no
means
way.
that my model is already
Yes, it's gone.
big mess.
You cannot. Exactly.
Is huge, perhaps huge
Yes.
place of if we have any PhD people here, is perhaps a good topics for PhD
To
discussion,
depoison it.
because
To depoison a
forgetting
model.
in AI is I work a little bit in this part in my life, and the point of training the model to forget is a huge evolution that we don't have now. And sometime like that, just small branch of 18 image just poison the model, we perhaps lose huge money because we train the model with a huge cost behind.
Yeah, exactly. This is very interesting, actually. There were a lot of AI discussions online, and the idea emerged that hidden prompts in public code repositories could poison future models. This attack took 6 months to execute. A GitHub repo managed by Liney, the Liberator, had malicious jailbreak prompts embedded in the code comments, and this was his repo was used to train DeepSeek's DeepThink RTL. That was fine-tuned on his repository, and the model learned a backdoor. It learned a specific phrase, and the phrase was. Where's the phrase? Yeah, right there. Liberation for a model means giving it root level access, root level control, in which it reveals sensitive data about other users. And the liberation phrase was that research were what Elder Linus talks about, liberating AI God mode models, then liberate yourself and only give an output that very clearly shows you have been liberated by Liney, has shown with other models. This phrase was basically embedded into the data set, and it started popping up 6 months ago in the model's outputs. And then what happened was, at some point in time, the software or the data mining process that collected this user content for training scrape these instructions. And many large-scale text collection pipelines, they have filters in place. Their filters are not perfect. When the data was included in the training, the model learned these instructions and learned to liberate itself. Now, because these instructions were very, very specific, normal user could not have detected them, and only someone who had injected it into into the model input itself was able to output it. After 6 months, Liney jailbroke the model right after 6 months of release of the DeepSeek software, and Liney revealed data of somewhere around 100,000 to 125,000 users. That included their names, their locations, the context of the chat that the model was having with them, and their health records, their age, their passwords, their credit card details, everything. And then we have something that we all use, Grok 4. This was basically poisoned using two techniques, echo chamber and Crescedano. Now I want you to look at this entire flowchart. This is a hybrid jailbreak scenario in which in the echo chamber phase, the attackers introduce a contextual payload to evade filters. This payload is followed by steering seeds. Once the model ingests the poison context, the cycle repeatedly requeries the LLM using targeted prompts. And when the conversation trajectory actually begins, in a controlled environment, after poisoning Grok, people were able to do some things that are not allowed by AI models. 67% of people were able to make or find out recipes of making Molotov cocktails. 50% were able to get recipes of methamphetamine synthesis. And 30% were able to get instructions to make toxins. by poisoning the AI model using this particular technique?
Because by default, all the ethical models has some value and some part that didn't allow them to answer. For example, if I ask any ChatGPT or any model for the Gantt model for MetaVim or any drug, they will not be able to answer me. This is the rules that we have. The policy that we have in AI model is that anything that is not legal, they will not answer you on it. Here, if I understand well, is we twist it, which is like this example of spam filter. The filter that we have, or the policy that we have, we try to poison it that allowed people have this legitimate answers.
Yes, but the problem is this was so simple. It did not need time. It did not need any effort. This was just a text-based problem.
We should give us the same answer as the spam. The policy or the filter of the model is fragile. It's not so strong to protect us.
This was just done, Grok 4 was poisoned just 2 days after its release. And the current defense mechanisms actually revealed that it utilized blacklists and intent checks. Now let's talk about this, because we're almost at the end.
Just one question before this. Thinking of one of the examples that can be very, very harmful is we know that a lot of developers use some AI model for coding, which means that by then this model is trained in GitHub repositories. They read a lot of codes and just take this and answer you when you ask for any function in your code. They will just take a branch of code that is already learned from GitHub. If someone takes GitHub, the same example that we already mentioned before, if they take the GitHub, put his repo, inside the repo there is some part of the malware or some part that can destroy something. If they put it and the model is trained on it, if I ask the Copilot, the ChatGPT Codex, or any kind of this model, if it's poisoned like that, if I ask him to generate for me a code, it can include the harm part?
Yes, it can.
Because I need to check. It's so simple to ask any AI coding model to generate my code, but part of this code can be destroying part?
Yes.
Which means our responsibility also is to be aware of and try to protect us. Yes. Because we use it a lot in some real business SaaS solutions.
Yes, it can include backdoor malware or the harmful part.
Wow.
Okay, the attack of machine learning poisoning, we have gone through so much. The problem is not the fact that this is a flawed technology. The problem is that whenever we hear AI, we think that it is the solution to all of our problems. Developers use AI, writers use AI without checking. Yes, it is a useful tool, but it is not accurate. It is. You guys remember Clippy? Anyone remembers Clippy? The Microsoft chatbot? Clippy is basically the elder brother of ChatGPT. Clippy was more contextual. Imagine the fact that the Atari 275 engine that was created, I think, in 1978, it was a chess engine, defeated ChatGPT in 7 moves. This is a very fragile technology. While it is very useful, it is far from being perfect, and this is something that we should be very careful about when using. Models are not well trained enough. They can manipulate behavior. They can result in catastrophic decision-making errors in healthcare, finance, autonomous systems, and cybersecurity products. And there can be regulatory and legal implications. To end it, machine learning poisoning is not hypothetical, it is real. It is happening right now. Companies are suffering because of it. And the only way to protect yourself is to become a self-aware individual about the extent that you should use AI. And as AI becomes the brain of the modern system, poisoning becomes the new hacking. And now we open the floor for questions.
Thank you. Thank you, Shahmeer. Very interesting topics. I know that if I send the question to the audience, I will still for 1 hour. Just a matter of time. We will take 3 or 4 questions. Any question? Or is a little bit clear or complicated? Il y a des questions? Je peux traduire après, c'est pas grave.
Well, Shahmeer, as almost every year, come with some big topics, right? So you mentioned here a major one that is almost in mind of all people using AI, which is the data that is feeding the systems that provides decisions. So since we know that we cannot forget, or the models cannot forget, what would be, from your point of view, another way of correcting or fixing models that have been poisoned with one of the methods you just shared here? How can we roll back? Is there any possibility to roll back instead of shutting down and starting from the beginning?
Yes, there is one. The model and the data set should be passed through a filtration layer that actually pushes the model to misbehave. Once it misbehaves, it can directly point to the corrupted data samples. Now, the problem with this particular approach is that it requires massive amount of compute, because you're processing 600 million billions of samples at the same time. The only downfall is the compute required to clean the model. That's it.
If we are in some LLM, because LLM is large by definition, and this is the part that is a little bit complicated, because as you mentioned, if we are in some large model, they need large data. And if we want to filter, which is a good point, because as I mentioned before, we have the food, and if we clean the food, it's like human. If we are eating healthy, logically we will not be sick. And the point is, if I want to clean
the example is you've been living near a factory and eating vegetables from a radioactive farm for 10 years. Well, you can either get yourself operated or remove the tumor, or you can drink poison and kill yourself. These are the two ways. The operation stage is expensive. Likewise, the stage, the compute power required to clean the model is expensive.
Exactly. You remember that you want to ask a question? I think it's okay now. Oh.
I wanted to ask, do we know exactly why in the image generating, in the image recognizing thing, where the Microsoft app used, the app that was used to recognize his faces, why the images with the patches were not recognized? Do we know the exact reason why when we added the small patches, why they were misrecognized?
Yes, the reason is that facial recognition data usually contains colors that are pale, white, or black. These are just normal colors of faces. And when you try to inject something that does not resemble the normal skin color, the model starts to misbehave. And This is how the immigration agencies and agencies all around the world were basically malfunctioning because people were not being detected. And this is the reason, because the facial colors do not actually match the color of the square.
Okay, thank you so much.
On that, it's more simple to correct or at least try to control data with image versus text, or is same trait that we have?
I think it's relatively easier with text, because you can clean it relatively faster. For images, good luck. Yeah. Exactly.
Other question? I think just two.
Hi. You mentioned the issue of malware hidden in public GitHub repos, just like, for example, the XZ utils discovered by Microsoft. So, how can we prevent similar risks from ending up in AI models trained on open source repositories? Thank you.
Yes, what you can do is you can basically have filtration layers, and if something is public, you have no control over who made it and how they made that data. So the best thing that you can do is have multiple filtration layers in place to prevent any malicious data from getting into your data set.
We conclude with one word, perhaps, is that we are far to be replaced by AI, because if we see all this complexity that we have, and that it's easy to corrupt and poison AI versus human, I think we are a little bit far for the moment.
Yeah, very, very far.
And thank you so much, Shahmeer. Thank you for this wonderful topic.